Dear co-chairs, dear colleagues, the study which we would like to share with you today is the attempt to answer the question: are nature-based solutions, and namely restoration of wetland ecosystem, applicable for termination of the permafrost thaw? Our study was supported by Belmont Forum, a Russian Fund for Fundamental Research, and Northern Forum. Our study is based on three hypotheses. One of them is that the permafrost thaw that we see the last several decades is explained not only by climate change, but also in large extent by the anthropogenic impact, like different types of physical disturbances, which are presented here on the picture and which we know very well, never, even if they don't cover a large area. That is why we have this second hypothesis that due to the impact on the permafrost, these very localized disturbances induce wider structural and functional changes in the landscape than one could expect. There is different physical processes which cause expansion of these destructions, but also due to the marginal effects of permafrost thaw, the effect is growing with years and causes many functional impacts on biodiversity, on the carbon exchange, on the water pollution, and so on and so hence, and due to the absence adequate rehabilitation measures in the Arctic, we have this problem of the accumulation of the disturbed areas over the years. And to be not so negative, we have the third hypothesis that the wetland ecosystem restoration is nevertheless the effective mechanism for permafrost thaw termination, and further we will look if it's true. Our study was carried out in the Nenets Autonomous Okrug. This is the European part of Russian Arctic. And the first step was to estimate the extent of the disturbances. Actually, the map of the disturbances already was done by Lavrinenko Igor and published in 2018. He was using the Sentinel-2 for the mapping, and we used this map in order to plan our more detailed sites, which we were planning to merge also with the permafrost study. We designated 5 pilot areas around 6,000–7,000 hectares each, in the points where group of Galina Malkova from Institute of Earth Cryosphere already had their calm boreholes, and in different landscapes, from terraces to deltas. For every pilot area, we estimated the percentage of the disturbed areas in line with the following classes: open sand, flooded areas with standing water, flooded areas in the streams, and open peat. This was including the new developments and expansion of old developments. The analysis of the area and the changing in the permafrost temperatures are still on the way. Since 2021, we are also studying disturbances on the large scale using the drones and analyzing orthophoto plans and organizing monitoring of the surface temperature uh, till 50 centimeters depth. And to get the proof of the impact of disturbances on the permafrost status, namely the active layer. We also were using the profiles and geophysical methods kindly provided by a group of Galina Malkova, and we can obviously see that under the drilling pad the permafrost thaw is larger, but it's not a surprise. Ecosystem restoration experiments have been set up in 2015, followed by monitoring. We can't organize permafrost monitoring in every point. That's why for us was significant to find good indicators for the permafrost restoration, or at least termination of further permafrost thawing. So in the transects we had identified parameters of vegetation like species composition and cover. For vascular plants, also height phenology to estimate the vitality of plants. And for soil, organic carbon content, moisture and temperature gradient up to 50 centimeters over the year, and depth of active layer. This is just to show you the example how we found the correlation between several species and the active layer depth. For example, ledum decumbens was found as a good indicator for the permafrost. It has strong negative correlation between the species characteristics and the permafrost depth, while Carex rediflora sedge was indifferent. It has exactly zero correlation with the permafrost. And for example, cowberry Vaccinium vicis idea has small negative correlation. So it shows that it is possible to form the list of species which will be good indicators for the presence of permafrost. The other type of indication is by the physical parameter measurable more easy than permafrost, and that is the temperature gradient from 0 to minus 15 in the soil. Doesn't need any sophisticated equipment, and the correlations are very good with the presence of active layer less than 1 meter, and the same, almost the same pattern of correlations are showed for the organic layer depths, what proves that the organic layer actually protects permafrost from thawing. And greenhouse gas story is obvious. We had several campaigns there, and the disturbed ecosystems are sources of greenhouse gases, non-disturbed are sinks of greenhouse gases, and the sites under restoration are not clear, but going to the sinks, towards the sinks. And generally, ecosystem restoration in Arctic should be introduced as a measure for the enhancing of the resilience of ecosystems to climate change, and first of all the protection of permafrost from thawing, restoring wetlands and peatlands. We are protecting permafrost, and we are keeping 1,500 gigatons of greenhouse gases still in the soil, preventing it coming to the atmosphere. And thank you very much for your attention.